Good day to you all. My name is Nikolai Sleptsov. I'm a 11th grade student of the Northeastern Federal University Lyceum, and I am also a member of the Hard Junior Science Academy. The development of modern technology requires new structural materials, what are superior in vein strength, elasticity, and that have our superior properties. One of the promising developments is the new polymer nanocomposites materials, what are made using mineral-layered clay minerals as fillers. In this study, I had carried out research on the polymer composite material properties and its structure, and have investigated the effects of Metamon 101, a organophilic nanoclay, on the polymer composite materials. This slide depicts a synthetic fluoropolymer polytetrafluoroethylene processing. As a filler, I've used the previously activated Metamon 101, Metamon 102, and made several samples of it. Then I've tested the properties of the resulting polymer composite materials. This table shows the results of the analysis of physical and mechanical properties. As you can see, the strain strength characteristic of this polymer decreases compared to the initial synthetic fluoropolymer, and depending on the Metamon 101, Metamon 102 concentration. Analysis of the results shows that adding the Metamon 101-102 to a synthetic fluoropolymer leads to a decreased rate of mass wear of the material. As we can see from this table, even adding 1% by weight of inactive Metamon 101-102, the wear resistance increases by 93-fold compared to the original polymer. The friction coefficient in comparison with unfilled polymer decreases slightly. To understand the composite properties, I have studied the surface morphology of the materials. There are photographs made by using a scanning electron microscope. Now you can see surface of sample A with 0.5%, sample B with 1%, sample C with 2%, sample D with 5%, and sample E with 10% content of montmorillonite. The filler in the polymer matrix is distributed randomly. Metamon particles serve as the center of crystallization. The formation of a two-phase heterogeneous mixture with a developed interface and a transition layer in which the mobility of the elements of the supramolecular structure increases was observed. This increases the rate of relaxation process, which helps to reduce local stresses in the polymer, leading to increase in vein strength characteristic. In conclusion, we can say what the filler flexibility and polymer matrix macromolecular conformational changes decrease polymer composite materials deformation strength characteristics. Use of layered silicates as modifiers of polymer matrix contributes to a significant improvement in polytetrafluoroethylene tribotechnical characteristic. The wear rate speed decreased 93-fold compared to the original polymer. The addition of the filler changed the polymer supramolecular structure morphology. Crystallization led to the formation of various polytetrafluoroethylene supramolecular structure elements. High wear-resistant friction surface polymer composite material with 2% content Metamon 101 Metamon 102 has a smoother surface with less roughness and fewer cracks. The friction surface silicate layer formation reduces the friction coefficient. Finally, I would like to express my sincere gratitude to my scientific supervisor Mrs. Елена Bakunova, scientific consultants Tatiana Struchkova and Italina Kolodeznikova, Dr. Varvara Neustroeva and Luisa Barieva. I also would like to thank the staff of the Polymer Nanocomposite Technologies Educational, Scientific and Technological Lab of the Arctic Innovation Center of the M.K. Amosov Northeastern Federal University. My school, M.K. Amosov Northeastern Federal University Lyceum, the SJSA.RU Junior Science Academy, and personally Dr. Vasily Pavlov for giving me an opportunity to present my project.